Hey everyone, and welcome to our channel. My name is Devashish and I am a BIM consultant at Chris. Today we are diving into the basics of something called Building Information Modeling. You must have heard of BIM from your colleagues, co-workers, clients, or maybe from your university professors. Well, even if you have not, I am not surprised. Large architectural and engineering companies are actively adopting BIM because they have the budget and resources to implement the right training to their employees. However, there is much confusion and lack of knowledge of BIM in the construction industry, especially amongst fresh graduates and small and medium-sized companies. Like if I take my example, I did civil engineering from the University of Sheffield. The university had good modules and courses, but they did not have BIM as a module. I graduated in 2016, but I had no clue what BIM was. I got first introduced to BIM during my master's studies in construction management, as it was an integrated module in my course. Well, I got lucky at the university. So if you are studying construction management or BIM courses, then there is a possibility that you get to know more about BIM and how to implement building information modeling on the construction projects. Well, I'm not the best guy to help you pick your courses or universities, so let's just get back to the topic. BIM is so new for many construction professionals. For muggles, it's like X-Men kind of things with lasers and simulations, AR, VR, etc. So till now, I'm not able to explain it to my colleagues and my friends and family that what do I do for a living. They usually go like this. He is doing something which has to do something with the 3D modeling and construction software. Well, there is a construction software, but it's not that complicated. So now let's dive into the main part of the video, which is what on the earth is BIM. So ladies and gentlemen, boys and girls, BIM stands for Building Information Modeling, not Building Intelligent Modeling, not Building Information Management, and definitely not Building Intelligent Mission. Man, there are some serious full forms of BIM all over the internet.
Oh man!
And BIM is not just 3D modeling. Neither it is a software. A decent definition of BIM could be, it is a construction management tool that streamlines construction management activities to control construction cost and time overruns. That's it. Simple. You can use BIM as a process to achieve your project goals, which for our construction projects are number 1, finishing the project within the estimated time, and number 2, within the estimated budget. But how BIM does it? Well, it does it by integrating critical project information of a building asset into a 3D model. The critical project information typically includes number 1, design information, number 2, construction timeline, number 3, cost information, and number 4, asset and life cycle details. Now that we have learned that BIM is neither a software nor just 3D modeling, it is a process or one of the construction management tools for controlling construction and time overruns. Great. Now let's quickly understand the dimensions of BIM. Please note we'll just learn some basics here and we'll dive into the dimensions in each of 3D, 4D, 5D and 6D part in the later part of the video. So number 1, 3D BIM. Basically, this is using 3D design information to develop a 3D model. This is generally known as 3D BIM. So yes, there is a 3D model in BIM, but that's not all. We'll discuss more about 3D BIM in the next section. For now, just understand that 3D BIM is the development of 3D architectural, structural, mechanical, electrical, plumbing models using a 3D modeling software such as Revit. And here we use the 2D design information developed by the architects and the engineers. Number 2, 4D BIM. This is the 4th dimension of time added to the 3D model. This typically includes a construction timeline. Well, now you'll think that we are time traveling doing the 4th dimension of time. Well, it simply means that integrating the details of your Gantt chart or construction timeline to the 3D model using a software, generally Navisworks. Number 3, adding the 5th dimension of cost to these 3D model is called 5D cost estimation. Now here you are integrating the cost information as per your location and the rates you are using. You can integrate the material information to your models and then do the further activities for developing the billing of quantities. Well, we'll do all of that in the next section. Number 4, adding the 6th dimension of life cycle details to these 3D model is called 6D facilities management, which is a highly effective tool for facilities manager. Well, that's it. It is as simple as it sounds, but it does include advanced softwares and 3D models. Maybe the muggles are right. Now, let's dive into how storing design information, cost information, asset and building lifecycle details, and construction timelines in the BIM process help in controlling costs and time overruns. So number one, storing design information. The idea of BIM is that the BIM team works parallelly with the design team. So this includes the development of 3D BIM models right from the conceptual stage, and which goes till the detailed design stage. The construction manager usually appoints a BIM team which consists of 3 disciplines. Number 1, architectural, number 2, structural, and number 3, MEP, which means each of these teams will initially develop a 3D model using the 2D CAD or hand-drawn sketches using the common software known as Revit. These BIM models contain design elements of each discipline in a 3-dimensional workspace. The design details typically include walls, doors, windows, foundation, columns, beams, rebar, pipes, HVAC switches, etc. etc. So you must have got this thing clear that BIM starts from developing a 3D model using the 2D design data. We initially develop 3 individual models of each discipline, and these models consist of generic elements which we usually implement in the construction. So as the design stage moves forward, these elements are populated with design information such as sections of columns, slabs, beams, reinforcement details, precise dimensions of the walls, doors design, windows elements, roofs, etc. So basically now when you click on any design element such as primary beam in the structural 3D model, it shall tell you its geometrical details such as its dimensions, sections, the kind of reinforcement used in that particular column. You can further add more details such as contractor details, volume, etc., which we will definitely discuss in the lifecycle management. So now we have 3D Revit models, commonly known as BIM models, from architectural, structural, and MEP disciplines. The next step in the model development is superimposing these models together to form a single model. After the design development is finished, we make one central model which consists of architectural, structural, and MEP models superimposing each other. However, there is a lot of chance that these models could be prone to clashes. This brings us to the next section known as clash detection. What is clash detection? Now, if you ask, how can you ensure that these Revit models that you have are developed, are precise in terms of accuracy as per the 2D drawings? Well, the answer is clash detection. The clash detection allows you to check the behavior of these design elements from one another, from one discipline to another. For example, you can check if the wall on floor number 1 is clashing with the pipe on the floor 1, or vice versa. The software commonly used for clash detection is Navisworks. In this, we first import all 3 Revit models in NWD format, set the tolerance rates, and start assessing the clashes. Using the defined parameters, the software tells us the exact location of the clashes occurring at different floors or location. You can generate a report of these clashes and share them with the architects and engineers to demonstrate the clashes occurring in the built asset. Using this report, the architects and engineer can further work on the design and rectify that these clashes are further captured by the BIM team in their Revit models. When the Revit models become clash-free, we move to the next step in the BIM process, which is 4D scheduling and simulation. As a construction manager, you are working with the project timelines and Gantt charts. In this step, we simply import the 3D Revit model in a software such as Navisworks and again assign the dates to the activities as per the project timeline or Gantt chart. For instance, the project timeline is for 2 years. We step by step assign the dates right from the excavation till the completion stage. Once we are done with assessing the dates, you can play the simulation and see the construction activities happening in a virtual 4D environment. 4D scheduling serves as a powerful tool for assessing and eliminating potential risks on the site during construction and prioritizing tasks. Number 4. Quantity takeoffs and cost estimation. So the design elements in the Revit models that we have developed in the architectural, structural, and MEP disciplines are populated with cost information. This includes the standard rates of materials as per your geographical location. So you define these rates to define design elements. Revit software offers a feature called quantity takeoff, which allow the users to extract the precise number of quantities in a sheet format. Example, you can extract precise number of columns, beams, doors, windows, slabs, etc. And using the rates that you have defined, Revit automatically develops a bill of quantity that you can use for forecasting costs. Making the cost assessment much easier for quantity surveys, this feature is quite awesome. Now that you have prioritized your construction activities and shortlisted the final design, the next step is the final step, which is the 6D facilities management. 6D, as the name suggests, in this step we add the sixth dimension of lifecycle details to the design elements. This includes integrating manufacturer contractor details, item IDs, item installation dates, maintenance schedules, configurations, service, warranty dates, etc. The reason why 6D BIM is a powerful tool is because we have all the possible details of elements installed in a building in a one single model. Using 6D BIM models, facilities managers can easily plan their maintenance activities and building owners can smartly plan their future renovation. So now you see the relevance of BIM in the construction industry. It not only gives you the 3D representation of your built asset, but it provides you a detailed, comprehensive overview of the elements installed in the building. How to use those elements, how to effectively manage them, how to assess their cost for better forecasts, and definitely how to manage the facilities better for potential future renovations, as well as the basic life cycle management.